purpose of this video is to help you see how to factor two different things. One's called the sum of squares, and the other one's called the difference of squares. So sum of squares is like sum of squares, like x squared plus 8x plus 16. That's an example of a sum of squares. Difference of squares is something like this, x squared minus 16. And so we'll look at both of those today. The main thing that we've been looking at so far is trying to identify patterns within our factoring. If I can see a pattern, like for example this one, this number is positive, so it means the signs have to be the same. They both have to be negative. So I know both of those are going to be negative there. And then I'm looking for numbers that multiply to 6, add to negative 5. Or down here I see the 2 out in front. So I can either guess and check. So I could write a 2x here and an x there, and then the 5. A 5 might go here, a 1 might go there. This sign is negative, so one has to be positive, one has to be negative. And then you would check that. I don't think this one works out, but you'd have to check that after. And that's a similar thing when we're looking at trinomial squares or sum of squares. A trinomial square, what we're looking for is a pattern. So you can recognize them by, if you can take the square root of a and c, then you might have a trinomial square. What? Just a second, let's try that. Okay, so here, what they're saying is that if I can take the square root of that and it come out even, then it might be a trinomial square. And that has to work for this thing, and it has to work for that term as well. So the square root of 36 is 6. Square root of t squared would just be a t. So maybe this is a trinomial square. Now, to factor something like that, if you have something like a square root there, and you always have to check these, but to factor that, what you could do then is split this t squared into t and t, split the 36 into 6 and 6, square root of that, right? And then since this is positive, both things have to be the same sign. They both have to be negative. That's what they're saying with that one. Now, I'd always have to check that. T squared minus 6t minus another 6t, that gives me minus 12t, minus 6 times minus 6, positive 36. That one works. So it works sometimes, but it doesn't work all the time. Let's try this one. So can I take the square root of the first one? Square root of 25 is 5. Yeah, I could do that. So 5 and 5. Square root of 4y squared. Yeah, I could take the square root of that evenly. So one's 2y, one's 2y. This sign's positive. Both signs are the same. They're both positive. And then I would FOIL it and multiply it out and just check. 5 times 5, 25. 5 times 2, that'd be 10y. And then 2y times 5 is another 10y. Those add up to 20y. 2y times 2y, 4y squared. That one works fine. So when we're looking for trinomial squares, we want to make sure things, I can take the square root of the first one, square root of the second one. Let's try it with this one. And maybe I'll just do this one, and you can try some of the other ones if you want. Square root of p squared is p, so p and p. Square root of 9, 3 and 3, got it. Oh, hold on now. So this sign is negative. So one of these, that means the signs have to be different. So this one would have to be plus, this one would have to be a minus. That's not going to be a trinomial square because these two aren't the same. Also, if you were to FOIL this, this doesn't come out to that, so this can't be right. That can't be right. This one would not be a trinomial square. Okay, I take a look at this one. I see a 5y squared. You can't square root 5. Not going to be a trinomial square. It doesn't mean that you can't factor it. You might be able to factor that, but it's not a trinomial square. Let's look at this one here. It's in the wrong order. 25a squared minus 30a plus 9. Can I take the square root of 25? Yeah. So this would be a 5a and a 5a. Square root of 9 is 3, so a 3 and a 3. Both same signs, both negative. Now let's just check. 25a squared minus 15 minus another 15. That gives me minus 30. Positive 9, that one works. Okay, hopefully that gives you the idea for the trinomial squares. Typically, if I can recognize those, great. But typically with those questions, I just take and factor them just the way I always factor something. And I don't specifically look for one like this where I could rewrite it 5a minus 3 squared. So a trinomial or a sum of squares. Typically I don't look at it that way. I just see if I can factor it the normal way that I always do. But if you can recognize the trinomial square, great. There's another couple, but you could try those later if you want. Okay, the other one is something called a difference of squares. And this is the one that's a little bit funny, because in this case here I only have two terms. So usually I have an x squared, like ax squared plus bx plus c, always three terms. But in this one I have something squared, but then there's only two terms. If you see something like this, especially when the second one doesn't have an x on it, and if you can take the square root of both of those, this is called the difference of two squares. And to factor that, I split up the x like I normally do. X, split up the 25, so it'd be 5 and a 5. And then, because this is minus, one's plus, one's minus. And these two are known as a difference of squares. I guess this is a difference of squares. And if I were to multiply this out, I'm going to get that. Watch. X times x, x squared. X times negative 5 is a negative 5x. 5 times x is a positive 5x. 5 times minus 5 is minus 25. Minus 5x plus 5x is 0, so those two terms cancel out, leaving me with that. Therefore, this is the proper difference of squares. Let's try a couple. You'll find that you might like these ones because they're the easiest ones. Can I take the square root of each? Yes. So I put a y there, y there. Square root of 36 is 6. One is plus, one's minus. Doesn't matter which order you put those in. They just have to be one of them positive, one of them negative. Ooh, this one looks a little bit tougher. So this would be a 16. I can take the square root of that. That'll be 4x squared and 4x squared. And then 49 separates to 7 and 7. One's minus, one's plus. Again, if you FOIL that out, you'll find you get that. Try this one down here. 4x squared, yeah, I can do that. So that's 2x and 2x. Oh, can't do anything with 15. Wouldn't be able to factor that one. I could solve that if it were an equation, but it's not a difference of squares. Let's try this one. 9w to the 6th. Oh, yeah, okay. So 9, I can take the square root of that. So it'd be a 3. If I take the square root of this, you're basically just cutting them in two. So I get a 3w3 here and a 3w3 there. Square root of 1 is 1. So a 1 and a 1. One's positive, one's negative. Done. This is a difference of squares. I have factored it. Let's just try a couple more. Maybe this one here might be a good one to try, because it's just, there's a couple little things that can happen with it. You could try these ones too. Notice this one isn't a difference, but if you were to rewrite it, 25t squared minus 49, then you could do the difference of squares thing. Let's try it with this one though. So 64, that would be 8x to the 4th, oh no, 8x squared and 8x squared. 81 to the 8th would be 9x to the 4th, 9x to the 4th. Cutting that one. One's positive, one's negative. Done. Could do the same thing there. Where's the one I wanted to try? Oh, this one. This is the one. 81x to the 4th. Okay, I can factor that. 81 square root of that is 9, so 9x squared, 9x squared. Square root of 1 is 1, so 1 and a 1. 1's positive, 1's negative. The interesting thing with this one is that this one here is another difference of squares. This one is a sum of squares. I can't factor that. This one's done. Can't do anything more with that. But this one I could split into two more factors. So 9x squared, I can split it into 3x and 3x. 1 times 1 is 1, so 1 and 1. 1's plus, 1's minus. So this would be the correct factorization. This one would be incomplete. You might get a 3 out of 5 or something on that one. Here's the last one with a fraction. Same kind of game though. 16, so I put a 4 and a 4. 1 over 81. So 1 over 81 would be 1/9 times 1/9. And then it's a y to the 8th, so this one would get 4 of them, and this would get 4 of them. 1's minus, 1's plus. Oh no, I could factor that one again. There's another, that's another good one. So 4 plus 1/9 y to the 4th. I leave that last one alone, but this one I can take the square root of 4 is 2 and 2. 1/9 would be 1/3 here and 1/3 there. Y to the 4th, so it'd be a y squared here, a y squared there. 1's minus, 1's plus. Okay, so hopefully that gives you a little bit of description of the two things we looked at, sum of squares and difference of squares. Try some questions.